In this segment, we'll talk about how to solve a first-order differential equation by using Ralston's method. I'm going to take an example in this particular segment. So this is part of the Runge-Kutta second-order method. Ralston's method is an example, is one of the forms of the Runge-Kutta second-order method. We're going to solve a first-order ordinary differential equation by doing so. And the differential equation which you're going to solve for the example is given as follows: dy by dx is equal to 3 e to the power minus x minus 0.4 y, y sub 0 equal to 5. So that's given to us as the differential equation, and we want to use Ralston's methods to be able to find out what the solution to this one is. To review what Ralston's method is based on that your value of y at the point where you are trying to go will be given by the point where you were, the value of y where you were, plus 1/3 the value of k1 plus 2/3 the value of k2 times the step size, which is h, where k1 is the slope at the point where you were, which is x of I, y of I, and k2 is some approximate value of the slope at a point which is about 3/4 away between the point where you are and where you are trying to go. So k1 and k2 are basically two slopes at this point and this point, and what we are doing, we're giving this 1/3 weightage, this 2/3 weightage, and using that to calculate what y sub I plus 1 is. And what we're going to do is we're going to assume that h is equal to 1.5 for this example. So if h is equal to 1.5, and what we want to do is we want to find out what y sub 3 is. So that's the complete description of the problem here, except for these formulas which I just showed for review, that you're using a step size of 1.5 and you want to find out what the value of y sub 3 is. So that means that you're going to take two steps, because the first step will give you the value of y at 1.5, the second step will give you the value at 3, because we are starting from y equal to x equal to 0. So let's go and go through the steps of Ralston's method and see what do we get. So we have I equal to 0, that's what I'm going to assume, I equal to 0. And now what is the value of x naught? X naught is 0 and y naught is 5, because if I'm going to choose my first point to be x equal to 0, then the corresponding value of y is 5. I'm going to find my k1 now. K1 is the value of the function at xi comma y sub I. So it will be x naught comma y sub naught. And that will be the function itself, which I should have written what the function is. The function is function of x and y. Function of x comma y is 3 to the power minus x minus 0.4 y, because that's simply the slope of y with respect to x. So that's the function f, which we know. So it will be f at 0 comma 5, so that will be 3 to the power minus 0 minus 0.4 times 5, and that gives you 1. So that's the value of k1 at x equal to 0. Now let's go and calculate k2. Now in order to calculate k2, I have to calculate the value of the function at 3/4 away from where I am. So 3 by 4h, then y sub I plus 3 by 4 k1 times h. So that's the corresponding value of x and y which I have to find. So in this case, I will get the value of the function f. X naught is 0, h is 1.5, y sub I know that is what, this is y naught here. Y naught is 5 plus 3 by 4, k1 is what, k1 I just found is 1, and h is 1.5. So you can see that what you are trying to do here in the second argument which you have, you are trying to find some approximate value of y at x equal to 3/4 away from where you were, because in order to be able to find the value of f, you do need the value of x, you need the value of y. So if I simplify this, I get f at 1.125 and 6.125. So this value of 6.125 which you have is an approximate value of y at this value of x, because that's what you want to be able to use to calculate your value of y at 1.5. This is 3/4 away between 0 and 1.5. So what do I get here? I get minus 1.4. Let me just substitute those values into the formula. So I'll have 3 e to the power minus 1.125 minus 0.4 times 6.125, and the value of K2 turns out to be minus 1.476. So now I have the values of K1 and K2, so I'll be able to use them in the formula to calculate my Y1. So Y1 is equal to Y naught plus 1/3 of K1 plus 2/3 of K2 times H. So what is Y naught? Y naught is 5 plus what is the value of K1, which I just calculated, was 1, and 2/3 the value of K2, which I just calculated, which was minus 1.476. And I multiplied by 1.5 because that's my step size of 1.5. So this number here turns out to be 5 plus minus 0.6507 times 1.5, and this value here turns out to be 4.024. So that is my approximate value of Y1, which is the approximate value of Y at x1, which is nothing but 1.5. The reason why x1 is 1.5 is because x1 is nothing but x naught plus h. X naught is 0, h is 1.5, so x1 is nothing but 1.5. So this 4.024 is just the approximate value of y at x equal to 1.5.